You're
They're
coming in
fine.
fine on my machine, Tom. So you're slightly brighter than the others, but not annoyingly so. So
You
it's,
want me
it's
to
all
go
right.
put my AES hat on? That will.
He's a bright guy. What can we do?
That's
Exactly.
Right. I was gonna say, yes. He's so bright. He just shines all over.
Maybe I should. Well, I just took a shower, so.
First is Tom Fine talking about the dawn of commercial digital recording. And then Paul Blakemore is going to talk about, take a deep look into the Soundstream system. Tom, are you going to want questions as people bring them up, or do you want them to hold them to the end?
No, we can go along. This is a small enough group. We can go as we go.
Okay.
I'm
Great.
actually a little nervous because this is a smarter and more distinguished group than I'm used to presenting to. I just usually do audio clubs.
So this is your opportunity to make Tom squirm, and you can look forward to that. Let me introduce my buddy Tom Fine to talk to us about the dawn of commercial digital recording. Tom.
All right. Thanks, Dan. I'm going to share my screen here. Okay. Perfect. All right. So I've given this presentation a few times, and I can't play the music examples, so I took all that out. But I updated the links and the information earlier this year, or I guess early in 2020, when I gave the presentation to the Connecticut Audio Society. So I hope all the links work. I sent a copy of the slides to Gary, Louie, and to Luke, and they can harvest the links and post the links in chat as we go. So if there's something you want to dive deep into as I go along, the links hopefully will be in chat. I'm happy to share a PDF of the slides when I'm done. Okay. All right, now how do I? Okay, I have to hit the. Okay, so I'm basically going to be summarizing an article that I wrote for the Association of Recorded Sound Collections journal about this, and it is hosted at the AES Historical Committee because the inspiration for it was Jay McKnight, who suggested that someone, well, he wanted a history of like the AES discussions and standards making on digital, but I was more interested in, how this came from, a telephony technology to recording music and what the route was. And so that's where my article ended up going. It wasn't really an AES journal article because it wasn't scientific enough. So the ARSC journal was the place to put it. And we can discuss and do Q&A as we go along. If something jumps out at you, just ask a question. So one thing that's interesting is digital recording is about 50 years old now. In fact, 1971 was when Denon released their first LP that was from a digital recording. And electrical recording was 50 years old in the mid 70s. So you think about how much progress from 1926 to 1976 with electrical recording and disc recording. And tape recording was 43 years old in the late 90s. And the CD is not yet 50 years old, and it may be submerged and non-existent by its 50th anniversary. So my point is that digital is a mature technology now for commercial music recording. And I show this slide mainly for the audiophile groups I talk to, because if you're still bitching about the 1982 sound of CDs, you have not, that's an antique. Things sound much better now. So we're going to mostly concentrate on PCM recording because it's been the mainstream digital format. And I don't know, DSD, I didn't get into it because the pioneering things were all PCM. PCM was first invented as a mechanical facsimile system, of course, by Western Electric, Bell Labs. And it was studied for voice transmission by IT&T and not commercialized. And that link is a good early history of PCM and digital down at the bottom there. The first use of it where voices were actually being quantized and sent over transmission lines and then converted back to analog was the Sig Sally system. And this is worth a deep dive if you're interested. This was a communication system with the Allies in World War II because the phone lines were being tapped. Do I hear a question? No. Okay. And the first peaceful use of PCM outside of telephony, it evolved in telephony in the background from the 40s through the 60s, and it was used for multiplexing of long distance phones and that sort of thing, which I don't fully understand because I'm not an EE, and I recommend Googling that if you're interested. But it came into use for audio, like the audio we think of, with broadcasting, for both in Japan and in Britain. It was used for transmitting by the BBC between broadcast centers and faraway transmitters, because phone lines could send PCM very well as compared to the degradation that would take place to far-flung transmitter towers of analog audio. The PBS system in this country tried a similar thing with their date system, and I don't know how long that was used or how widely deployed, but it was described in that SMPTE journal article that's referenced. Now, Denon, and I'm now going to have to take a 10,500 foot view because we have a distinguished guest who was actually a first person participant, and I don't want to mangle the history. But Denon was the first company to get serious about and succeed with digital recording of music that was commercially released. So they joined in with some research that had been done by NHK, the Japanese broadcaster, which by the late 60s had developed working PCM digital recorders. And Denon joined forces and leased the NHK 2-channel recorder, and then made the first commercial digital recordings. They later developed an 8-channel machine, and they developed a multi-track machine that was used for jazz recordings that you could actually, mix down from and everything. And this was in the 1970s, and they were actively releasing digital recordings throughout the 1970s. There's an ARSC journal article that detailed their history. Lead author was Mr. Anazawa, who passed, but who I was fortunate to have a lot of email with while I was doing my research for this. This is the NHK 2-channel recorder that the first Denon recordings were made with. This is the...
Hey, Tom.
Yes.
This is extremely silly and trivial, but have I been saying it wrong all these years by saying Denon?
I don't know. I call it Denon. I've heard it called Denon. I don't know.
Tom.
Yes.
This is the very first album which was produced using NHK's a PCM machine, two-channel machine. This record was released in 1971, real first one.
Is that the Steve Marcus record?
This is the Steve Marcus. This is the Stomu Yamashita. This is the very first, not recorded with NHK machine. Steve Marcus recorded using Denon machine. This was recorded with NHK. Real first one in the world.
Okay.
Yeah.
So that was but wasn't the Steve Marcus one released at the same time?
No, a little later.
Really? Okay. All right. Well, that part of the history's been corrected. Thank you, Yukio.
Are you showing us something else? Or yes.
Tom,
Yes.
again, Tom, sorry.
Yes.
Tom, I'd like to be back again. This is a demonstration record of
Yes.
first PCM recording.
Yes.
And this record includes a track from the recording of Steve Marcus.
Yes.
Yeah.
I was going to show that. That's about 2 slides later.
Oh, really? Okay. I read through that. Sorry for that.
No,
Great,
no worries. Thank you.
And Tom, if I can ask here, did Yukio get big for everybody there when I spotlighted him?
No, we still have the Tom's screen share.
Still a thumbnail. Okay.
We should after I get done with a couple of more slides, maybe I could unshare my screen and we could have full size Yukio and
yes,
he could tell us about those early recordings. Because this is great having a first person there. So
Tom, did you take these pictures in Tokyo yourself?
no, Mr. Anazawa sent them to me.
I see. Okay.
Yeah.
Okay. That was my machine. I was working on this machine for many years. It's really nice to see this picture.
Really?
Yeah, really.
So what do you remember anything specific about it that we should note?
Yes, a specification is exactly as what you wrote in your presentation, but this machine was first developed with the 13-bit ADCs, AD converters, but later the AD converter module was upgraded, adding 1 more bit. And finally, the machine got 14-bit ADCs. And from the second machine, we always used 14 bits. But this machine,
that tracks with what Mr. Anazawa told me.
Yep.
He was very patient explaining this to me via email.
I see. Okay. Yeah. He was my direct boss and a very good teacher. He taught me everything about teacher and everything.
He was a very nice man.
Great mind.
Yeah. So there is Dr. Anazawa, and this is the later machine, right, Yukio?
This is the first machine. This is a 023.
Oh, that's the 023. Okay.
Yes, the very first one.
Okay. So
yes.
Yukio just showed this. There is one of these on eBay for $129 right now.
Oh no.
Which tempts me because it is a rare artifact. This is the first introduction of an LP with digitally recorded content, correct, Yukio?
Yes.
And so one thing I wanted to highlight with this is that Denon was using the PCM recording as part of a larger strategy to improve the sound of the LP record. So they were not only doing digital recording, they also had what they called non-distortion cutting, and the combination of those things was what they were presenting as their innovation, this master sonic system.
Do we know technically what non-distortion cutting entailed?
That was a kind of technique which reduces the tracing distortion of the LPs. And for example, Dyna Group from RCA. Yeah, and many record companies at that time tried to develop the system which reduces the tracing noise from the stylus of the pickups by adding canceling signals before the cutting of the groups. And the system which Denon developed by themselves was master sonic. So actually, this is the technique to improve the sound of LPs. And in this big family of master sonic technique appeared one new technique. That was digital recording, PCM recording. Yeah, you see here. And Tom, I should correct what I said. There's something of Steve Marcus was recorded using NHK machine, as you said. That's right, because the date of the issue of this record is the 71. No, it's 1971. So this recording was made using NHK machine. You are right. You are right.
What I find is interesting about this record is that Denon not afraid. They're bold. On side A, they say, "Hey, here's our innovation." Side B, this is the way we used to do it. You take a listen and you make your choice.
Mm-hmm.
And I admire that.
Without knowing more technical details, it sounded similar to some of the Dynagroove methods.
Exactly, the similar.
So you would pre-distort the groove?
Yes, right.
Interesting.
Yeah, the system is really a huge one, and many researchers in our company was engaged in developing this.
Now, was yours the problem with the RCA system in this country was that the end result with the pre-distorting of the groove, it played fine on their players, but it sounded lousy on most other players. So
Yes,
how did you get around that? How did you make yours work generically?
The result of one research showed us that these pre-distorted systems, what's their act when this group is reproduced using another kind of stylus, for example, the elliptical stylus or so. The result is that the sound will not be worse than the original. The improvement is not so much as when it's reproduced with the round stylus. This kind of system is working, presuming the reproduce will be made using round stylus. Yeah, and
spherical or conical, you mean?
The conical, yes, conical. Yeah, the normal conical, the classical stylus.
I have a question, Yukio.
Yes.
I used to work for RCA Victor here in Toronto, Canada, in the early 60s when they were fooling around with Dynagroove and the pre-distortion and so on. We were cutting mono discs on a Scully lathe with a Westrex cutting head, and we were cutting stereo discs on a Neumann lathe using a Westrex 3D cutting head. And in theory, we would run the audio through a rack full of equipment that the RCA engineering people had made for us, and that would provide the pre-distortion that was required for the Dynagroove process. But I always wondered whether or not an elliptical stylus might have been able to play some of the Dynagroove stuff a lot better and get better results, but I'm not entirely sure that they were readily available at the time we were doing this.
Mm-hmm. I read a paper recently about this. I don't know where the source was, but it showed that paper showed what kind of shape the stylus has. The result of the reproduction of a pre-distorted record is will not be worse than the original. Yeah. So of course this kind of system shows the best result when the record is reproduced with normal conical stylus.
Yeah.
If using other kind of stylus, the result will not be worse than the original. I read so.
All I can say, Tom.
Unfortunately, Dynagroove took a lot of hits in the reviewing press because of the fact that the Dynagroove recordings just simply didn't sound as good as other recordings, and nobody seemed to be able to figure out why. So I'm at a loss too, for that matter.
Graham, I have a thing. Oh,
Sorry.
no, you go ahead, Yukio.
Yeah, I'm a big lover of LP records still now. I'm listening to LP records every day, and I have also an impression as other LP lovers. The original LPs, which appeared in the 1950s or early 60s, before Dynagroove, they listened much better than the records in the Dynagroove age.
Were you able to compare an LP that was issued prior to Dynagroove with a reissue of the same LP with the Dynagroove process applied? Were you able to compare those two?
I didn't do that, but I can do it, of course. For example, there's some records recorded with Boston Symphony Orchestra under the direction of Eric Leinsdorf. So they were cut in different way. The first original was cut without Dynagroove because it appeared at the beginning of 1960s, and that record was reissued using Dynagroove at the late 60s. I can do that, but I haven't done it yet. But in my impression, the record in the late 60s in Dynagroove age, they have a bit different sound. It lost a life of sound.
So I have a theory about that. I think that rack of equipment that Graham was talking about, there was probably a whole bunch of tubes and transformers in that the signal was going through. And I also suspect that the cutting engineer had less leeway because, part of the beauty of those 1958 through 1960 RCA and other early stereo cuts was that the ones that succeeded, the cutting engineer was doing all new things. And a lot of times they were doing they were figuring things out as they went. Now, if you're at an RCA cutting room and someone puts a rack of equipment in there between the tape and the lathe, I would imagine your choices are somewhat limited at that point. Is that true, Graham?
Well, I can tell you from memory, the rack that we used was patched in to the cutting room equipment, and the rack contained a whole bunch of things, including a couple of Pultec EQP1A equalizers, and a bunch of things that, if I remember correctly, were Fairchild modular limiting devices. And there's no telling exactly what this rack full of stuff did to the sound that was coming off the 15 IPS 2-track tapes that were the source of the recordings that we were cutting. In Toronto, we used to receive 10-inch tapes from RCA Victor, New York, and these were considered to be our master tapes for the lacquers that we were cutting for distribution in Canada. And if Dynagroove was to be applied, these tapes were routed through the Dynagroove rack. And like I say, they didn't really tell us very much about what it was supposed to be doing, because we didn't have much that we could do to tweak it.
Well, can we get back to digital? Because otherwise we will be here all night. But we should talk about disc, the disc cutting another time, definitely.
I was just to say.
Tom, may I say only one thing very shortly?
Yes.
Yes, I am not against the pre-distorted system. I am respecting that. That only because the discussion about sound is a bit different from this system. The idea of the non-pre-distortion system is genius, brilliant. That the people involved in the research of this were all genius. Only the time was that implementation was not ideal. If this idea is realized today using digital technique, the result will be really perfect and will solve all problems completely without any degradation of sound. I'm respecting this system, these systems, or system, Dyna Group, whatever it is.
Yeah, the only thing I was going to say very briefly, Tom, is at least my understanding is that Dynagroove wasn't just pre-distortion. There was also all kinds of stuff relating to Fletcher Munson and various other processing. So it's
that would explain the rack of equalizers and compressors.
Yeah. So unfortunately, it's not really possible here 60 years later to entirely separate, Dynagroove pre-distortion versus Dynagroove everything else. So that's all.
I think you're right. Anyways, let's go back to digital, but we definitely should talk about disc cutting one of these days. So I just wanted to list some of the Denon firsts. Yoshio, please speak up if I'm wrong about this, but my understanding is that something was recorded before the Japanese album. That it was the first thing they did because Steve Marcus was over there in 1970 touring, and he got in the studio with those guys and made that album.
That's quite right. And something by Steve Marcus and the Storm Yamashita perhaps at the same time.
Okay.
Yeah.
And then the first classical album that I could find was the Mozart String Quartets in 1972.
Yes, the first classical music recording using the Denon's own system. The album of Storm Yamashita is also a kind of classical music. It's a contemporary music. But you are right. You are quite right.
And then the Bach musical offering was the first all-digital recording in Western Europe.
This is not 100% correct, because in these recordings made in France by making a recording tour to France, taking our DN023R recording system. And the very, very first recording was Mozart.
Oh.
Perhaps some days before, or 1 week before this Bach, Mozart was recorded. In that sense, this is not completely correct, but 98% correct.
Okay. Well, yeah. Well, you know what? I'll fix that. If you email me the Mozart recording, I will fix that slide for future presentations. And then Denon took a recording trip to New York to Sound Ideas studio in 1977. And the discographies I found has the first album that was recorded was Archie Shepp's album in that series of recordings.
That is very, very correct.
And they used.
Tom, this is the first Mozart. This is the first recording in Europe, made in Europe. Mozart.
Okay.
After this appeared Bach. A few days after.
Okay.
All right.
I'm really happy that Yukio is here, because where, you know, this, I'm trying, I've always made this point in the presentations, and Denon was first. We have to respect that. They were there first. They did this first. They did a lot of R&D and you know, a lot of progress in the art of digital recording before anyone else was doing it commercially. Now we move to the US to Soundstream.
Yeah.
And I'm going to take a 10,000-foot view on this because Paul's going to go into great detail about this next. But I watched Dr. Stockham's presentation at the AES tape summit thing in the 90s. And he was doing experiments with PCM recording as early as 1969 at the University of Utah. And in fact, produced a monophonic PCM recorder that used a computer tape drive as the storage medium. And his idea was to record radio broadcasts, overnight radio broadcasts that he liked to listen to for background music. So he also developed the first computer-based waveform editor and DSP audio level and EQ adjustment programs, which there's a Sound on Sound or recording engineer producer article that shows screenshots of these in the Soundstream computer center. They evolved. He founded his company in 75, and they first came out with a 16-bit 37.5 sampling rate, and they made recordings in Santa Fe, which they played at the AES convention that year, which created quite a stir. And the next year, they went along on recording trips with Burt White with Crystal Clear Records, and they had improved their machine to 42.5 kilohertz sampling rate. And the Soundstream recordings of those Virgil Fox, which was released as the Digital Fox, those are actually alternate takes. They're not the same takes that were used on the direct-to-disc recordings. What happened is that the two partners of Crystal Clear Records separated, and their agreement was that one of them kept the metal parts for the records and the other one kept the PCM tapes. But the guy with the PCM tapes couldn't release the same takes as were on the LP records. You know, as you know, with direct-to-disc recording, it's a complete take, and they would cut several sides of things to have a choice of takes. And there would also be problems with the lathe. There'd be problems with microphones, et cetera, et cetera. That's why the direct-to-disc fad didn't last too long in this country. The December 77 session is interesting because that was the first session I read about or heard about, at least in the US, where it was direct to disc with a tape backup and with a digital backup. And Burt White was somehow juggling all three of these systems with Stan Ricker running the lathe. I talked to Jerry Bruck, who was the recording engineer for New Worlds Records at that Santa Fe Opera recording session. And this is his quote about this, tells you about digital operating levels. I knew we were dealing with something different when Tom Stockham called me on the intercom to say he had noted a hum on our feed. Surprised, I turned our monitor speaker up but heard nothing amiss. I asked him what level he thought it was at. He called back, "It's about 80 dB down." And Jerry's reaction was awk, because of course no tape machine cares about something 80 dB down, and most analog consoles and monitors of the time didn't have an 80 dB dynamic range. Then came Telarc. So the Telarc guys, and Paul will correct me if I'm wrong on any of this, they heard the Soundstream system at the AES. That Telarc was launched as a direct-to-disc label, and they heard the Soundstream system at AES and got talking with Dr. Stockham, and he did some test recordings with them, and Jack Renner didn't like that the he still said there was something screwy on the top end, even with the 42.5 kilohertz sampling rate, which I assume was probably filter artifacts down in the high frequency, the audible high frequencies, but I don't really know. But Jack had good ears, so he said to Stockham, "Can you raise the sampling rate to push this out of the audible band?" And Stockham said, "Yes, I think I can," and that's where you get to the 50 kilohertz 16-bit production Soundstream format. And the first US classical all digital recording was the bass drum heard round the world, the Fred Fennell recording of the Holst suites, which he had done in mono for Mercury many years prior. So Soundstream and Telarc had a multi-year many album relationship. The Soundstream was also used a lot by Delos, and RCA. RCA actually, when Soundstream went out of business, RCA had a full editing system and computer and continued to use the Soundstream system for a while. Paul will probably be able to give us more details on how things wound up with Telarc when they moved on to other systems. This is what the Soundstream looks like. Paul's going to have much better pictures, but the unit over here is this is the digital interface. The tape recorder is a Honeywell instrumentation recorder, and all the digital stuff is taking place in this box and just going to the tape transport. And there are level meters to the side here, and then this is the level slider on each one. And Paul's going to go into more detail and have closer up pictures, which is good now that I'm looking on a little screen. This is better when you have a projector. There's Tom Stockham at the first Telarc recording session in Cleveland. And the next innovation was 3M. And this is where digital came into a production environment that pop and rock people could deal with. Because up until this point, the Soundstream system was, you could link these things together. RCA actually made an 8-track Soundstream recording with 4 units linked together, but you couldn't punch in and punch out and this sort of thing. The 3M system they licensed PCM technology from the BBC, but they used their own expertise in tape recorders, and they came up with the 3M digital mastering system. So I remember that 1977 AES convention. I went to it with my father, and I remember that 3M made quite a stir. They had a huge booth, and I unfortunately threw out, at some point after college, I threw out my old literature from these things. But I remember 3M gave you a bag of swag and, a big brochure. And I think they had maybe a demo LP or something. It was a lot of cool stuff. And the machine was huge, and, it had wood panels. It was the kind of thing AES convention goers would be flocking around. I think that I am not sure at that point that they actually could demonstrate 32 working tracks. I think the next year was when they actually had a production 32-track machine working. But their machine used a specially formulated 1-inch tape. It went at 45 IPS, and it was 16 bits, 50 kilohertz, and you could edit the tapes, and you could punch in and out on the tapes. The record companies used it. TV and movie sound companies used it. You could link it up with SMPTE time code. I've heard stories of, loading docks full of 3M machines at, I think it was MGM, it might have been Disney, just out in the sun after they abandoned the format. But the Hollywood studios went in big for this, because you can imagine that, this was noiseless, and, you could do all your dubbing and overdubbing and sync to picture and all of this.
Tom, was the editing that you talk about physical editing or electronic editing?
I think it was physical, and I'm not sure how it works, but they had an edit.
Like they had a big Editol splicing block.
Yeah, I think you spliced it. But I think it made if I remember correctly, the splice angle was weird. And I'm not sure. I don't know. I think you would have to, the way you would mark your edits, it would line it up at specific sample points, maybe. I've never seen one of these things in action. So I'm not, you know what? I'm not going to say. I'm taking a 10,000.
Probably something like when you would edit a 2-inch videotape where you'd have to do the splices that the frame breaks.
I think it may, you know what? I don't think so, because it was a linear system, as I recall. So it was like the dash. I think you could edit the dash tapes with a splicing block.
Can I join?
Yes.
As long as I remember, the 3M digital recording system was cut by hand, I think.
Yeah, you could edit with a splicing block, right?
Yes, and in Denon also, I can tell a little bit about that. We spliced the tape. We made editing by hand. We were using 3M type VTR. The tape had a width of 2 inches, and recording was made nearly vertically on the tape, running with a speed of 15 inches per second. And using a splicing block, we cut between tracks. Therefore, we had to use a microscope, putting a metal powder on it, and visually we found a place to splice exactly millimeter, much less than millimeter, and there we cut exactly along the recording track. And so I edited it myself for years, really many years I did it. So my right ear is weaker than the left ear.
So you would need to line up frames, video frames.
Yes, not the video frame. Normally video frame, it means the frame between vertical synchronous synchro signals. But editing is what cannot be made this precision. The precision of the editing must be much higher than that. Therefore, we cut the track using the precision of horizontal how can I say frequency.
Okay.
Yeah.
Wow.
So therefore, that was a strong work for my right eye, looking through a microscope.
You must be incredibly strongly left-brained.
Yes, that was that time. Therefore, we from this experience, we thought there is a limit to work in this way, and adding hand splicing, we put a digital circuit which makes the crossfade. Yeah, digitally. The machine sensed the exact splice place by optical sensor, and the digital machine, digital system made a crossfading from the trigger from this sensor. And so the track itself was spliced by hand physically, but the signal was edited using crossfade through this digital circuit. That was the way which we worked for many years, and that it didn't work anymore in that way. Therefore, we developed a digital editing. I developed the digital editing system using of non-distraction editing using a memory and computer.
Did the Mitsubishi X80 system work similar to your crossfade? Because I remember that had an analog track that you would scrub the audio with, and then you would splice it with a splicing block, as I recall.
Yes, I think so. Yes.
So I assume that they were doing a digital crossfade with that splice.
I think so. I think so. I think so.
Yeah.
They didn't have the editing system. The machine had to be edited by hand. Surprisingly.
Right. So maybe 3M did work that way because I do recall the 3M system being editable with a splicing block. That was one of the things that they talked about with it. And the other thing is, I'm sure the way it was used by Warner Brothers to make rock and roll records, I am sure no one was going to sit there and with a microscope and line up edits. So, I think just in the production of the kind of records that it was used for, there had to have been an easier editing method than that. But all these years that I've researched this, I've never found a 3M veteran. So if anyone knows anyone still alive who worked on the 3M digital system, I would love to talk to them. So the interesting thing about 3M is they had their prototype installed at Sound 80 Studios in Minneapolis, and they were testing it out. They named it Herbie because the studio was owned by Herb Pilhofer. And there was a session that was supposed to be direct to disc, but the LP cutter didn't work very well. The 3M machine was used as a backup. They listened to the results and actually thought the digital sounded better than what they were getting. They had a highly customized and highly bulky LP cutter from what I've been told, and it was very bulky that day. So they ended up liking the digital results, and so once the LP cutter started behaving, they cut their record from that. It ended up being a great performance because, again, this was a live session. It was it was intended to be direct to disc, so it was, every section of this, every side of this music was live with no editing and no overdubs, and the LP turned out to be a very nice chamber music record, and it won a Grammy. And then the 3M system was used on the first all digital rock album, which was Ry Cooder's "Bop Till You Drop." And if any of you have ever heard the CD of that, the CD is a better way to hear it because the LP, some of the digital pops and ticks were hidden in the LP surface noise. But if you listen to the CD, there's many things that advanced better. Let's put it that way. By the time Pro Tools came along, this is what the 3M looked like. And Tom, can you mute yourself? This is what the 3M looked like. It was a massive machine. It looked like more like a normal multi-track tape machine, and it definitely behaved that way. But it was very expensive. I think they ended up having to lease them. I think basically a lot of them ended up in Hollywood because Hollywood could afford them, and Warner Brothers Records was a heavy user. They could afford them. But, your average independent studio, not very many of them could afford this system. This is what the 3M ads looked like in those days. Lee Hirschberg was a big user of this system and recorded a lot of albums that sold a lot of copies, a lot of gold records that he recorded making with the 3M system. This ad is interesting. This is the 1, 2, 3, 4 da 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 dum of Beethoven's Fifth as represented by digital words off the 3M system. I thought that was a cool concept for an ad.
Tom?
Yes.
One factor for 3M and Hollywood is that I think the machine was developed at the Camarillo facility, which is just up the road.
Right. Yeah, probably. I mean, I think that format was very useful for Hollywood for big scoring sessions because, you had none of the generation loss mixing down for a film soundtrack where something could be down 3 or 4 generations by the time it gets on a print. So moving along, because I don't want to cheat Paul here. I want to get to Paul. The European classical companies especially went the route of developing their own machines. Decca came up with an 18-bit 48K system that used an IVC video recorder for storage. And they used this well into the 80s. And I think there is still one working Decca machine with a former Decca engineer, but all the tapes that were recorded this way have been transferred into the Universal Classics digital archive by now. EMI also built their own recorder. They used a 1-inch industrial data tape recorder and came up with 14 bits, 50 kilohertz.
Hey, Tom,
Yes.
can I tell you a funny story about the Decca machine?
Sure.
I was talking to John Dunkerley, who is one of the Decca classical recording engineers, and he told me this hilarious story that when they developed their digital machine, they wanted to be able to monitor off tape, just like they had done with their analog machines. And that video recorder was a rotating head, helical scan machine, and they were noisy, and so they would put the transports in another room from the control room, but they had a remote control where they could switch between input monitor and tape monitor. And he said one time they did a session and they'd been monitoring off tape and everything went just fine. And they went to do playback and they discovered that there was nothing there. And what had happened is the transport had failed, but the head was still spinning and recording over and playing back from the same loop of tape continuously. So there was nothing on the reel of tape, but they had heard it off tape during the entire take.
Oh, man, they needed a tape op to be watching that if it was in another room. That's funny.
I did that. She didn't do that too.
One of the big problems with any of this digital stuff, I'll bet you, would be interchangeability, so that you could take a tape recorded on one machine and properly play it back on another. I ran into this with Mitsubishi. I was sent a tape that had been recorded on a Mitsubishi machine way back when, and we literally searched all over the world to find somebody that would have a machine that could play this back. You could play it and listen to the single analog track, but you could not get it to sync and play back digitally as it should. So interchangeability for Mitsubishi at least was an unmitigated disaster.
Well, I've transferred a fair number of DATs, and DATs had so up through DATs that was a problem. Some DATs that are recorded on some machines don't play back on some other machines.
When I was a teacher, we used portable DAT machines for students to do field recording, and we had to actually have the student, when they turned in the tape, write the serial number of the machine it was recorded on, because sometimes that was the only one that would play it.
Yeah. Well, I remember when my mother was doing the CD remastering in the 90s, Polygram Studios standardized on Panasonic DAT machines. And they told her, if you want a DAT machine at home, buy a Panasonic, because what you make at the studio is going to work on a Panasonic. It may not work on a Sony. And I do find that to be true, that her DATs play back on my Panasonic machine fine. They don't play back all of them on the Sony machine just fine. Sometimes they have dropouts, and vice versa. Something recorded on the Sony machine doesn't always play back on the Panasonic machine. So anyway, this is what the Decca recorder looked like. I assume there was a front panel to this unit, and I'm not sure what all the units exactly did. I harvested this off the web. I'm going to stay at 10,000 feet on this, given the company. This is what the EMI unit looked like, and then the polygram labels stuck with existing systems. So Deutsche Grammophon actually DG was an extensive user of the 3M system, and they still have a working 3M machine in Germany. They used the 3M system for years. And Philips, they used Sony equipment, but they also, their first actual digital recording was done by Decca engineers using the Soundstream recorder. So it was kind of a funny thing. But their first recordings in Holland and in Europe used off-the-shelf Sony equipment because they were very late to the party. This is what the first Deutsche Grammophon album looks like, and that's what the Philips one is cool. This is an actual strip on the top of it. And RCA and Columbia came in about the same time the Decca and EMI came in, and RCA went heavily into the Soundstream system. Columbia tried the 3M system but didn't stick with it. They ended up using Sony equipment mostly because they were owned by Sony. And then RCA did an interesting thing that was covered in Billboard. Paul Goodman engineered a session that they had 4 synchronized Soundstream machines to make an 8-track recording that I assume he then dumped all of that into the computer and did his editing and mixing, and probably did at least his editing in the computer and then mixed out of the computer. But maybe Paul will have some insights as to how that was done. These were what the first RCA and Columbia albums looked like. And so this is a little discography. This is something by Steve Marcus. This purported to be an original first pressing LP that I grabbed the snaps off of eBay. This was reissued on CD, by the way, and it also streamed. There's a good stream of this on YouTube, and I'm just amazed by how this sounds with PCM 1970. You could get good digital sound from day one with this, and if your 1982 CD sounds crappy, it's because you didn't do it well. It was there was 10 years of learning that showed you could do this well by the time the CD came along. This is the Bach musical offering, but now I'm told the Mozart is actually the first commercial recording. This is the Archie Shepp record that I have a CD of that. Now this is the first Telarc digital record. And one thing that Telarc had going for it that I should mention is that Stan Ricker was a hell of a disc cutter. So, he could cut that full dynamic range, and they would have the discs plated, and I think they had them pressed it by Europa disc or Teldec, so that they were not run-of-the-mill crappy American pressings. They were sent to Europe. They were well pressed. They were well plated. Stan Ricker could cut a hell of a disc, and they would edit the thing on the Soundstream computer and then dump it back to a master tape. And Stan would half-speed cut from the master tape, which of course is nothing with digital. It's not a big deal to cut it, to run the tape at half speed. You don't need a whole bunch of different EQ filters and all this. Not to mention trying to do Dolby at half speed. So it was much easier to do this the way from the Soundstream. The Sound 80 was a run-of-the-mill US LP, but it was well pressed. I think it was pressed by RCA, and like I said, that was a surprise Grammy winner, but quite a nice sound to it. The Decca, of course, had impeccable cutting and pressing, so they would make a nice LP. EMI also in England. And of course, Deutsche Grammophon. And then the Rycooter, it's just a run-of-the-mill Warner Brothers record, but they did have a sticker on it, Rock's first all-digital recording. And that's it from me. But if there's any questions or comments, let's do them.
I have one. When you were talking about Sig Sally early on, I got logged out of Zoom somehow and missed making this comment then. But Sig Sally was a secure communications methodology for the first digital transmission.
Right, first
thing.
Voice transmission.
Yeah, and it used albums that were random sounds recorded onto disc by recording engineers, and one of them was at the transmitting spot and the other was at the receiving spot, and they started them at the same moment and used those random world sounds like traffic noises or whatever as the encoding or the carrier signal, I guess. Maybe somebody else here knows more about this than I do, but they superimposed the digital audio on this random sounds on the send side and used the receiving record, which was going in exactly the same speed, to decode it. And it was secure. And it let the generals and the presidents and the world leaders communicate securely. And Frank Lako was one of the engineers who made those records for them. He was in the Army and
yeah,
and did that. So I think that's a real interesting and fun sidebar.
You know, the random encoding signal, there were two discs made at one time.
Yes.
And they were coded so that the receiving end had the same disc for the message that you might be sending. They ran about 15 minutes apiece. So then they had to change them, and they couldn't use them twice. And if they were used, they were supposed to be destroyed afterwards. So
were they masking the audio? Were they masking the digital audio?
Well, my understanding is that they were juggling the spectrum, the audio spectrum around. So, but maybe I'm talking about something different. I don't know.
There's an audio AES presentation on Sig Sally. Could dig it out.
Yeah, and it's too bad Bob Smith had to leave because he knows a lot about this more than I do. So
interesting.
There we go.
Anybody else?
Yeah, I'll pop in just kind of a fun little side note, and Paul can corroborate this for me perhaps, but I heard that Stan Ricker also helped to tune the bass drum at that session, because the tuning of the drum was part of what gave it the impact. And I know Fennell was really fussy about bass drums. When I played for him as a bassoonist, he would always bring his own bass drum beater when he came to conduct. But I think Stan had a lot to do with how great that record sounded.
Yeah, and I know that they moved the bass drum into the center so that it would be largely lateral rather than cut vertically on the stereo.
Yeah, aimed directly at the mics when typically most engineers said, please don't do that to me.
Yeah. Yeah.
Well, anybody have any other further comments?
Can I make a comment question, Tom?
Yeah, sure, Rich.
For all I know, the answer to this could be another whole presentation. But I think I've talked to you a little bit about how my experiments and research into sound design and electronic music has continued. And I was just watching an interview with Laurie Spiegel the other day, and she was talking about being around at the advent of digital recording and stuff. So I was just wondering to what extent the field of sound design and electronic music contributed to the development of digital audio.
I don't know. I think that this kind of digital, like PCM recording and stuff, came more out of telephony than out, because I think digital music kind of rode on what came out of the telephony developments. And the this, like the NHK got interested in this, as I understand it. The Japanese aesthetic on sound, the way I read it, is they don't like tape hiss. So they never like tape hiss, and they don't like the dubbing losses. So they were always interested in something that had a more present and dynamic sound. And NHK got experimenting with this as a recording system, and then came up with one that worked. And then Denon, as we heard before, they were interested in this as part of a means of improving the LP record, for the consumer, and for how music was released by LP records. As I understand it, with the electronic music, that kind of evolved in the analog world, right? With filters and modulators and oscillators.
Yeah, well, I'm referring to how, what I've read of the history being that Laurie Spiegel was at Bell Labs in the 70s with Max Matthews, and they had created this groove system, which was like a digital analog hybrid electronic instrument.
Yes, I was actually, Laurie Spiegel is a very close friend of mine. But in those days, don't forget, this was originally created on a PDP-11 computer, not something somebody would own in their home. So it was not common. And I worked in electronic music for a long while, and everything was analog because we could afford the gear. I mean, I worked in electronic music even in the 70s, but it was all analog. But she was doing this. Then later, when digital came along, I know it was a revelation to me, because you could create and edit with a computer and do more things. But for me, that started, I bought the first digital synthesizer that I bought was like in the 1980s.
Mm-hmm.
Didn't the digital synthesis stuff, didn't that come out of Japan? Didn't that evolve more in Japan?
Yeah,
that's a good question. I don't know the answer to that.
A lot of it came through Roland, who really came out of the back of Hammond and a couple of other companies. A couple of people got into doing the sort of digital synthesis thing. So most started off with frequency modulation, but that went down a whole rabbit hole that Yamaha kept going. But the digital stuff was like Korg, Yamaha, and Roland were all developing stuff by themselves, all about at the same time. It was one of those, everybody had the same idea, different implementations of it. So you ended up with frequency modulation, and then PCM, and then sample and synthesis, which was a Roland thing initially, where they had a tiny little sample of the actual sound right at the very, very beginning of the attack of the sound, and then the rest of it was synthesized digitally.
I do remember when I was in college, you could mess around with this stuff on. Now I'm blanking out. It was a kind of computer that was before Apple that had
get the Commodore, CBM Commodore.
Yeah, Commodore.
Well, and Atari also had a computer that had a lot of music functions built into it.
Yeah.
At that time, a little
think
one.
you'll find
But my first digital synthesizer, way before you could have small computers, was a very big, expensive Kurzweil, which was totally an American, as far as I know, it was totally American design. Because I actually met Ray Kurzweil.
We should do a synthesizer history.
I'd love to do that, because I've used a lot of them over the years, and all that. The history of electronic music, switching from analog into digital, because once digital came along, I felt so free to do stuff. The analog, I knew somebody that tried to do a piece where the first note would be, the attack would be a piano, and then there'd be a voice, and they had to splice hundreds and hundreds of splices over a period of weeks. Now you can do that on Pro Tools in 2 hours. Yeah.
I think you'll find that synthesis has many, many originators. Because the idea was at hand, and the technology was at hand for people who had access to computers. I happened to be working in 68 and 69 for a small computer manufacturer in the Boston area that had a hybrid digital analog computer. And they were mostly going for design and graphics and computer assisted design. But one of the engineers hooked up an amplifier to the computer and was doing primitive stuff with synthesis back then, just because you could. And I doubt that you're going to find like a linear progression of this person did it first and then that person.
There are a lot of people trying it.
Yeah.
Well, what was the name of that company you're talking about?
Because was Adage Incorporated.
Oh yeah, I've heard of that. Yeah.
I think the company still exists.
Yeah, maybe. But I know there's a lot of stuff. People tried stuff. I remember the first time I went to a computer show and saw voice synthesis, people recording and playing back voice. I don't mean inventing it from text. And I was so shocked because computers were so crude in those days. I thought, wow, this is so great. You can hear something. But yeah, you're right. It's a lot of different people at a lot of different places. But they weren't necessarily all doing it for electronic music. A lot of them were just doing it because they wanted to see how they could use their computers for sound.
Yeah.
And guys, this would be a fascinating discussion to have, and I propose we do it, but let's get back to Tom's talk here.
I should yield the floor to Paul at this point. I think my thing is wound down.
Well, I actually have something for you, Tom, possibly. Do you have anything regarding, I think most of us probably know the kind of general basis for specifications was, based on Nyquist Shannon. But obviously, like with Redbook, that was kind of based around being able to fit digital audio onto a commercial videotape.
Yes.
Do you can you speak at all to the evolution, or I don't know if you can call it evolution, but the various standards through some of these early systems, why they were picked, what was because we're using this type of storage system, or because somebody said we have to have X many bits, or things like that.
Well, I think I would let an actual Denon person speak to Denon. I know Sony in their early research always was trying to fit digital into videotape. So what they came up with and what they ultimately imposed on the industry was what could fit on their videotape machines. They did make a few proprietary digital recorders. They were always behind Denon. That's why they've not been mentioned in my presentation. But they were always interested in fitting things in a video frame. The Soundstream, as you heard, they could increase the sampling rate, and they did increase the sampling rate because Telarc asked them to, and Telarc was ready to employ them long term to make recordings. Now, I assume that 3M had the same standard because Telarc was selling records and making a lot of hay with a 50 kilohertz sampling system. And I think there was a lot of pushback, including, like, my father did a whole presentation at the AES New York section, blasting the Redbook standard, saying it's not a high enough sampling rate, it's not a deep enough bit rate. I think he would have been impressed by the CDs my mother ended up making, but the early CDs didn't sound very good. And I don't think it was because of the standard, but there was a lot of pushback about 44.1 kilohertz. People couldn't believe that you wouldn't just chop a waveform up at 20 kilohertz, which it's not true. I mean, the Nyquist theory works, but the top end problems were anti-aliasing filters. There was jitter problems. There was a whole bunch of things that didn't have to do with the standard that you could hear that were problems with early digital stuff. But I think that as everyone was doing their own thing until basically Sony got involved and imposed on everyone. Sony and Philips invented the CD and said, look, we can't have quad 2. We can't have 8-track versus cassette. We need one standard. If we're going to have a digital mass medium, it's going to be one standard. And this is the standard. We can fit this on a 5-inch disc. It fits in video frames for all of the major video standards. So you can have a Redbook CD made in Australia. You can have a Redbook CD made in Japan. You can have a Redbook CD made with our crappy NTSC standard, and you can have a Redbook CD made with PAL. With PAL, there's room to spare. Anyway, so that's what it came down to, basically, is that there was a whole bunch of non-compatible systems. And then Sony and Philips invented something that actually could be manufactured and actually could be a standard, and pretty much imposed it on everybody.
But also remember, Tom, Sony was very interested in the money aspect. They were annoyed that when the compact cassette came out, that people could copy them and do them on their own. So when they brought out CD, they didn't realize that you could ever make a recordable CD for the user, so that they thought now you'd have to go back to LP days. You have to buy one if you wanted a copy.
Oh, yeah.
And then, but it didn't work because people invented that. But then they brought out the SACD, you cannot burn a one-off SACD. You can burn off a DSD file, but SACD won't necessarily play it.
Right.
And so, because they just were so concerned forever and ever, they wanted to have to make you buy a disc. You couldn't make copies,
Yes,
and they
I
didn't
know,
realize
and
how
it's-
many musicians were actually using recordable CDs, for their demos and stuff. They just ignored that whole market. They just wanted to go back to the days you had to go to the music store and buy something.
Well, actually, I mean, they had a two-pronged attack, really. So prong one was they wanted to sell a hell of a lot of U-matic machines, right? So this is great. Now, not only news gathering, but now sell this to the record companies. So that was prong one. Prong two is, get everyone to rebuy their music collection in this new format that they can't copy. So yes, that was definitely, Sony was definitely, I mean, look, they've made a lot of innovations over time, but they didn't leave a dollar on the table anywhere that they didn't have to.
And David had a comment. Did your comment get addressed there, David? Go ahead.
So about the early CDs sounding bad, there are a couple of things. One is that the earliest Sony processors by default were undithered, which means that you had what they call digital deafness toward the bottom, that the reverb tails would suddenly turn into the sound like cheesecloth being torn.
Yes.
There's a kind of granular distortion. And starting with the 1610, there was a switch that you could throw, dither or not dither, but people didn't know that mostly. I got put through a training course at Sony for that machine because I was, long story what I was doing, but basically if you wanted the best signal to noise specifications, you would want to measure the PCM processor with the dither turned off, because that way the noise floor was lower. And that's what Sony did in order to maintain specifications on paper. And then they delivered all these processors with dither switched off, and the studios just plugged them in and used them.
Yes.
So that was a part of it. Another part of it was that the master tapes, the analog master tapes that were used for record production. I was working at RCA Studios at one point, so I heard a good number of master tapes for records that had won all kinds of prizes and that audiophiles thought were absolutely wonderful. Those master tapes didn't sound like the LPs. Okay, they sounded horrible when you played them back. Compressed, limited, they were 6th, 7th generation copies.
Right, they weren't master tapes.
Well, they were master tapes if you understand that to mean they are the proximate source of the lacquer master for disc cutting.
Oh, I see.
For disc pressing. But what in our jargon we called the session tapes were called job tapes.
Okay.
Okay, that happened to be the language used at RCA. Other companies probably it was different. But what a lot of record companies did was to take their master tapes, which were the mixed, compressed, equalized, approved, producer-approved copies, and they transferred those directly to digital and then put out the CDs.
Right.
And that's just not the way to do it. You got to go back to.
You actually need to master a CD.
Correct. And because what the record companies thought at first, or at least some of the ones that I was in or had anything to do with. They thought, oh, this is great. We can cut out the mastering engineers completely.
Yes.
Those people whose fees drive up the cost of record production, and those records got horrible reviews, and they basically tucked their tails between their legs and went back to people like Bob Ludwig and people who knew what they were doing to make them sound good. And okay, so that's what I want.
To be more, if I can here, Luke, to be more specific about that point, I heard a talk by Vlado Meller, who was a mastering engineer at Columbia and is still doing it today, where he said that people were doing what David just said, companies were doing what David just said. And he pointed out that when you're mastering for an LP, you are, as the grooves as you get into the center of the record, they're slamming the high end to get more out of it as it gets to the middle. And they were using those tapes that had that accentuated
diameter equalization, it's called.
Yeah. So, okay, Luke.
Well, I was just going to say yes to everything David said, but also it depended because sometimes, master tapes were used and, those early CDs are now, some of the best places to get essentially flat transfers of the masters or, not to take away anything that he said, but also there's lots of exceptions and, or sometimes those EQ'd for LP tapes did end up sounding better than what somebody else did with a flat, the original master or things like that. So it's one of those things that you kind of have to be careful about because I know, people often say, oh, those early CDs are garbage. Well, some were, but some for one reason or another, which you can get into all kinds of discussions with, but actually do hold up for various reasons and are, well regarded.
I completely agree with that. There were companies, especially smaller companies, that were extremely careful to work from transparent copies or even the original materials when they made their CDs.
Yes.
Also, the PCM 1600. This was in 1610. I was trained on them both. They required a careful adjustment process every time you moved them from one place to another or into rooms with different temperatures to adjust the analog to digital converters. They had these ladder type converters where you basically made an adjustment for each of the bits so that it made the transition to the next bit up. And if you didn't make those adjustments, they would have increasing distortion with lower levels. And I really don't think, our training class at Sony was small and they only had 2 or 3 of those classes ever. And I really think that most of the studios were just plugging in the machines and running them. And as they deteriorated, they got more and more distortion. Those things needed a really careful setup.
Yeah, I think
and fairly frequently. And then every year you were supposed to send the converters back to their manufacturer for total recalibration, which cost something like $600 per converter. And again, I really doubt that the studios were paying those fees and doing that.
Sony, again, wanting to take every dollar off the table. Anyways, though, we should go to Paul Blakemore.
Yeah, we're going to, before we do that, let's thank Tom for that great presentation, everybody. That was really wonderful. Could you introduce yourself and say your connection to audio and where you are?
Yeah, hi, I'm in Nashville, Tennessee. I'm the staff mastering engineer for Concord Music, which is the largest independent music company in the world. It consists of several frontline labels, a deep catalog label, and then a huge amount of music publishing. And I have a studio in downtown Nashville where I'm sitting right now. I've been very lucky. I've been a full-time audio professional for over 40 years. I'm a Grammy winner. I'm an 8 times Grammy nominee in engineering categories. And I'm just recently moved to Nashville. I used to be based in Cleveland. I started with the company working for Telarc in 2000, and Concord bought Telarc in 2006, I think it was. And then when the company was reorganized, I migrated into being the staff mastering engineer for Concord. So, should I go ahead with this Soundstream?
Yes, please.
Okay. So I'm going to talk about my relationship with the Soundstream recorder and give some background on how it works. A disclaimer here, I am not an electrical engineer. I'm an audio guy, and so a great deal of what goes on inside the Soundstream machine is above my pay grade. I studied the manual extensively to try to understand exactly what was going on inside, but I'm sure that a lot of other folks in this group can shed a lot more insight on details of how the circuitry is working and how the logic works. I first became familiar with the Soundstream digital recording system in 2000, long after its heyday, which was from about 1976 to about 1982. My first project when I started to work at Telarc was to prepare their early Soundstream masters for re-release on SACD. Soundstream used a 50 kilohertz sampling rate, so the first CD releases of these recordings were downsampled to 44.1 with some loss of their true fidelity. When SACD came along, Telarc decided to reissue many of their classic early Soundstream recordings. I used a custom-made DCS 972 digital-to-digital converter, which upsampled the 50 kilohertz PCM data to a DSD bit stream, and then remastered these releases using a Sonoma DSD workstation. I became fascinated by the Soundstream system's technology, which was very advanced when it was originally introduced back in 1976. The Soundstream Digital Recording Company was founded in 1975 by Dr. Thomas Stockham. He was formerly on the faculty at MIT, but when he founded Soundstream, he was on the computer science faculty at the University of Utah. The idea to start a digital recording company was suggested to him by Malcolm Lowe, who was the L in KLH, and he was also living in Utah during the early development of 3D computer graphics. Stockham had been working with digital audio since about 1963, when at MIT he and Amar Bose used an 11-bit 22 kilohertz sampling rate digital system in the development of an early Bose loudspeaker design. Soundstream first used a system similar to this one to record performances of the Santa Fe Opera in '76. That system used a 37.5 kilohertz sampling rate with 16-bit conversion and had an audio bandpass of 15 kilohertz. That recording was never released commercially, but was played in a demonstration at the 55th AES convention in New York in October of 1976. The first commercially released classical album that was recorded and edited using Soundstream was done by recording engineer Jack Renner and producer Bob Woods on the Telarc label. The April 1978 recording of the Cleveland Symphonic Winds, conducted by Frederick Fennell, was hugely successful and helped launch the digital recording era. The original release in 1978 was on LP phonograph record that was cut using the Soundstream digital master as the source. The machine that was used for this session had improvements suggested by Renner and Woods and used a 50 kilohertz sampling rate 16-bit. By 1981, Soundstream had been used for over 500 recordings, mostly classical. Soundstream also invented computer-based hard disk audio editing. The editing system ran on a Digital Equipment Recording Corporation model PDP 1160 mini computer, which is not exactly portable. So Soundstream had a permanent editing suite in Salt Lake City. The editing software was written by Robert Ingebretson from Soundstream. The DEC computer was equipped with two 14-inch Bragan hard disk drives with limited storage capacity. a small excerpt of 2 takes to be edited together was loaded onto the drives in order to locate exact edit points. The completed edit was inserted back into a master tape with the computer and Soundstream digital tape recorder controlled by software. It was a very slow process. The recording that we're going to listen to shortly was both edited and mixed digitally in the hard disk-based editing system. More about this later. Here is an overview of the technical operation of the Soundstream system. Here's a brief overview of how Soundstream system works. Oh, I'm sorry. Go back. Here's a brief overview of how the Soundstream system works. Soundstream is a 4-channel recording and playback system which was originally created for making digital masters for cutting onto LP phonograph records. Remember, this system predates compact disc by about 6 years, so LP records were still the delivery medium for commercial music recordings during the height of the system's use. 2 channels contained the stereo audio program. The other 2 channels contained a preview of the audio advanced in time by the amount needed to feed the variable pitch and depth controls on a cutting lathe. The electronics cabinet is divided into 3 sections. Oh, there we go. Electronics cabinet is divided into 3 sections. Towards the rear are the power supplies. In the center are master clock, various logic cards to control the transport during recording and playback, data transmitter cards, interface cards that translate data into serial bit streams for the tape transport, bit synchronizer cards that turn the sine wave representation of the data from tape back into TTL compatible pulse signals for playback, and comparators that switch between the redundant data tracks from tape. In the front section are anti-aliasing low-pass filters, A to D converters, D to A converters, repro low-pass filters, and output buffer amplifiers. The underside of the electronics card frame is all hand-wired point-to-point. I can't imagine putting these things together. As I mentioned earlier, the sampling rate is 50 kilohertz. The sampling frequency and other clocks needed for control of the electronics and transport are all derived from a 2 megahertz crystal oscillator that is housed in the electronics unit. The individual cards that are used in the various card slots are also all hand wired. In record mode, analog audio is first fed into a transformerless balanced input amplifier followed by a record volume slider on the front panel. That's the sliders that you can see in between the 2 numerical scales on each one of the channel's VU meters. From the input...
Paul,
yeah.
you mind if I ask a question, or do you want to wait till the end?
Oh, go ahead.
Who built these?
You know, I don't know. They were built in Salt Lake, so I'm assuming that they had some kind of a staff there. But I don't know. I don't know anything about the manufacturing details.
And are those wires soldered or wire wrapped?
On the underside, those are soldered, but on the underside of the frame, those are all wire wrapped.
Neat.
Yeah, it's crazy to me. I mean, you can imagine the amount of work just physical labor that it took to put one of these things together.
And then the other thing I just wanted to for you to point out to the group, the A to D and D to A converters are off the shelf.
Yeah, I'll get to those in just a minute.
Okay.
It looks like the main frame of a telephone central office.
Yeah.
One thing I could comment about is it looks very much like some of the work I was dealing with when I worked at Tektronix when they were dealing with prototypes. So it's almost looking like that.
Yeah. Well, the machines were all handmade, and I don't think any 2 of them were exactly alike. I don't know how many were actually manufactured. I think that there are still 2, possibly 3 that are operational. So that's the circuit card. So from the input volume controls, audio goes into an anti-aliasing low-pass filter with a bandpass of about 24 kilohertz, less than half the sampling frequency of 50 kilohertz sampling rate. That's the filters. An analogic MP8016 16-bit A to D converter converts each sample of the audio into a 16-bit integer at the 50 kilohertz sampling rate. From there, the data goes to a data transmitter card, which computes an even parity bit and adds this plus 3 synchronization bits to each 16-bit integer, forming a 20-bit word. The data transmitter card does this for all 4 audio channels and sends these as serial bit streams to an interface card that prepares the data for recording onto tape. There are 2 data outputs for each audio channel, which are sent to 2 separate record tracks on the tape. This is the foundation for the error detection and correction scheme used by Soundstream. Data and control signals, including a clock for the capstan motor servo, is sent via ribbon cables from the electronics unit to the transport. In this picture, the ribbon cables are only shown for reproduce, not for record. So there would be additional ribbon cables if you were actually using this system for recording. I had it set up just for playback for these photos. And the cables connect to parallel connectors on the side of the transport. The tape transport was manufactured by Honeywell for the military. It's mil spec and thus is built like a tank and weighs a ton. In the record mode, the capstan motor servo is controlled by the master clock from the electronics. Tape speed is either 30 or 35 inches per second, depending on a speed switch located inside the electronics unit. Oops, what did I just do? Okay, I don't know what I did, but anyway. Okay. This is one of the most interesting parts of the machine. The recorder uses stationary heads with a very narrow gap to achieve the bandwidth needed for digital recording. The frequency response is about 400 Hz to 500 kHz. There are separate erase and record reproduce heads. The heads actually have 18 data tracks. 2 edge tracks are dedicated to recording SMPTE time code, so are not pictured in this diagram that you see. Data for each audio channel is recorded to or played back from redundant pairs of tracks. The error correction circuits in the electronics unit compare the 2 tracks used for a single audio channel and switch between the 2 to avoid dropouts. The primary data tracks are the first 8 tracks on the top half of the 1-inch tape, and the redundant tracks are on the lower half of the 1-inch tape. So each primary data track and its redundant track are separated by about a ½ inch-ish as you move down the track layout on the tape. The pairs of tracks are not physically adjacent to each other, but rather are physically separated by about ½ inch of tape. This is to provide a more robust error correction. Small flaws in the oxide emulsion, which is magnetized to hold the data, are less likely to cover a large surface area of the tape. There is a routing switcher. Let's see. Yeah, this is just another view with detail if you want to look at this for a minute before I continue. All right, we'll move on. 4 data tracks are used for stereo recording, 2 for the left and 2 for the right channel. But the machine is capable of 4-channel recording, which uses 8 tracks. However, all 16 data tracks can be utilized for the 4 audio channels because there is a routing switcher built into the transport. This eliminates wasted recording space on each tape. All 16 tracks can be utilized even though there are only 4 needed for stereo and 8 are needed for 4-channel recording.
Hey, Paul?
Yeah.
I think you're talking about the last slide. It seemed like, at least that I thought I saw, yeah.
Yeah, but this is the actual routing switcher control, and what you do is you assign sets of tracks to the 4 audio channels. So, for example, in this picture, tracks 3 and 4 and their redundant tracks 6 and 8 are assigned to audio channels 1 and 2, and data tracks 5 and 6 and their redundant tracks 10 and 12 are assigned to audio channels 3 and 4. So you could essentially have 2 sides to the tape, even though you don't actually turn the tape over. You could wind the tape back to the beginning and record on the unused tracks. So you get twice as much use out of each reel.
Paul,
so
what is the control with the spring around it?
Oh, that's just a lid latch, typical military spec overbuilt. The lid just pushes down on this pin and springs back up when the latch is released, enabled by this spring.
So essentially, it's capable of 8 total tracks of operation, but there's only electronics for
4 audio channels, exactly.
Okay, I was trying to read and understand what that was all saying, and it wasn't making sense, but now it makes sense.
Okay. This slide illustrates the relationship between the paired data tracks, primary and redundant, and the available stereo audio tracks 1 and 2, 3 and 4, 5 and 6, 7, 8, each of which is made up of 4 data tracks. So, see, track 1 is paired with data track 9 to make 1 audio channel. Data track 2 is paired with data track 10 to make 1 audio channel. So it would take 4 tracks to record 2 channels. But you have 16 tracks on the tape, so you could have 4 audio channels represented on one pass of the tape by tracks, for example, 1 and 2, or by tracks 1 and 9, 2 and 10, 3 and 11, 4 and 12, and another pass represented by 5 and what would be 13, 6 and 14, 7 and 15, 8 and 16. And this switcher control on the front of the transport is how you assign those groups of tracks to the audio channels in the electronics box. Does that make sense?
Yes.
Okay. Threading the tape onto the transport is different from other tape machines you may have used. Most tape machines have a simple path straight off the feed reel through the headstack, capstan drive, and onto the take-up reel. The Soundstream is what's called a B-wind machine. The heads face up towards the top of the transport rather than down, and so the oxide emulsion must therefore face towards the bottom of the transport, and so to accomplish that, the tape comes off of the reel this way, so that the tape is actually going backwards. So the oxide at this point is on this side, But when it makes the turn, see now the oxide is pointed on the downside. It goes around these idlers and then across the heads, which are positioned here, through another capstan like this. There's actually two capstans with, there's no pinch rollers. There's two capstans with a knurled surface to grab the back coating of the tape. So see, this is oxide facing this on this side. On this side, this is the back coating of the tape, so it goes around these scored idlers or capstans. There's a smooth one to further smooth the travel of the tape in the center, and then winds back around to go onto the take-up reel, and to get it so that, again, the oxide is facing in on the reel, it turns a corner and wraps this way. So in the record or play mode, it looks like the reels are turning backwards, but it's just because of this weird threading path. And when we're all done, I've sent a video to Luke that we're going to try to show, so you can actually see this thing in action. Let me find where I am. Okay, so the layout of the heads is there's an erase head on this side of the head block, and then a single record or repro head on the right side of the head block. And here's, you can see the data tracks on the record repro head, and just a close-up of the guides and the capstans. And you can see how the drive capstans have this scored surface to grab the back coating on the tape. Okay, in this illustration, the azimuth of the record playhead is set up correctly. The pair of identical tracks 1 and 9 on the tape are exactly perpendicular to the head gap, as you can see in this illustration. This is highly exaggerated, but in this illustration the azimuth is set incorrectly, so that tracks 1 and 9, which are the pair, or one of the pairs of redundant tracks on the head, are angled relative to the tape gap, and so one of the tracks will read slightly earlier in time than the other, which screws up the ability of the error correction circuitry to tell what's going on. Of course, the slight angle of the head gap is not actually visible to the naked eye, as shown in this highly exaggerated drawing. The magnetized domains in the tape that represent digital data are microscopic, as is the head gap, but you can nonetheless see the actual time delay caused by an out of azimuth condition by using an oscilloscope. And so you connect the scope to a pair of redundant tracks. So these are the individual track outputs on B and C connectors on the side of the transport. So if you wanted to set the azimuth, you could use 1 and 9, you could use 3 and 11, and you look at this on a dual trace scope. And so this is what it looks like. One of the tracks, I think because of, let's see, let me get where I am. Yeah, one of the tracks, because it's controlling the scope's sync, stays stationary, and the other track will appear to be moving wiggling back and forth. And also, again, when we show this video, you'll be able to see what this looks like. So the idea in setting the azimuth is to set this starting point for these two streams to be roughly aligned with each other vertically. So this slide here shows an out of azimuth condition where this open space in the waveform does not line up with this open space on the other waveform. So the idea is to adjust the azimuth screw so that this lines up with this.
So were we looking at, was the top one track and the bottom another track, or was it?
Yes, this would represent, for example, track 1, and this would represent track 9. It's redundant pair. And in this slide here, the azimuth is set incorrectly because this starting point, this opening in the waveform does not correspond to this. It's off by, however much.
To be clear, so when it says wiggles left and right, does that mean as you're adjusting the azimuth?
No. When you look at this, you'll be able to see this when we look at the video. When you see this on the scope is synchronizing to one of these two inputs, and so the input that the scope is synchronized to will remain stationary, and the other input to the dual trace scope will appear to be wiggling back and forth like this, and you'll see what this looks like when we show the video. It'll make a lot more sense. This is just a stationary shot taken in a deliberately out of azimuth condition.
Okay.
So what you do is you adjust this azimuth screw, just like on any machine, so that you move this open space over this bottom trace open space, and this is what the correct azimuth adjustment ends up looking like. These two open spaces are lined up over each other. Now this track continues to move back and forth, to wiggle left and right when you look at it on the scope, but you can tell when you're in a close enough ballpark. It's not as critical as lining up like a 15K tone on an analog tape recorder where you're going for the tightest possible Lissajous display on an XY scope. It's not as critical, but if it's too far out of azimuth, the error correction circuitry will not work, and you'll have a lot of dropouts in the audio. And
presumably this is all coming off of an alignment tape from the...
No, this is coming off of just the data that's recorded onto the tape from the moment you enter record. I don't know that there were ever any alignment tapes, made for these machines. You would just have to set the repro azimuth to match the record azimuth every time you put up a new reel of tape. There's possible that the service manual describes some kind of procedure for setting this up initially. I did not find it in the manual. You guys may have a better, if you're interested in pouring through that manual, I sent everybody a Dropbox download link that has the complete service manual scanned.
Yeah, you don't really need an alignment tape. The data is good enough to set your azimuth.
Right.
The record head was fixed azimuth.
Yeah, but as a starting point, it would be nice to know that the head is in basically a good position to start with. But in my experience of working with multiple tapes, playing these back when I was doing these SACD remasters, is that you would have to recheck the azimuth for every single reel of tape that you put up on the machine. Let's see. Let me see where I am here. Okay, yeah, here we go. As you probably noticed in this picture, the data coming from the tape is a sine wave rather than a square wave representing the data pulses. This is because the bandwidth of the tape is not sufficient to record very high frequency pulses, so the edges of the pulses are rounded off into sine waves. However, there is a bit synchronizer card in the electronics that converts this bipolar sine wave back into TTL compatible pulses. I don't understand the operation of how this card does this. That's one thing that remains a mystery to me. Perhaps somebody who's a real double E could explain that at the end of the presentation. Each of the two redundant data tracks is processed by separate TTL conversion electronics. A comparison circuit selects the higher amplitude of these pairs of redundant signals and routes the best one to a first in, first out memory chip, a FIFO. The output of this memory buffer is fed to the digital to analog converter for conversion back to audio. The status of this data stream can be observed on the data transmitter cards, which are equipped with pairs of LEDs that represent the primary and redundant data tracks from the tape. So if you look at these cards, there's these two LEDs, and these are constantly blinking back and forth as it selects which of the two, the primary and the redundant tracks, is the higher amplitude of the two signals. And on a tape that's in really good condition, it will read primarily the primary track, and you'll just see the redundant track blink occasionally. But when the tape is in bad condition due to some kind of oxide deterioration, these things will be blinking quite frequently. Here's an interesting detail about the clocking of the machine on playback. I mentioned that in the record mode, the capstan servo is controlled directly by the master crystal oscillator in the electronics. However, on playback, the capstan servo is controlled by a voltage control oscillator that is driven by the output of the first in, first out memory chip that's receiving data from the bit synchronizer card. This assures that the data coming from the tape does not exceed the capacity of the FIFO memory buffer. And so it's controlling the tape speed so that there's not a data overrun into the FIFO. The voltage control oscillator actually varies the playback speed of the tape for optimum data throughput to the DAC. The digital to analog converter was originally an analogic MP1926. This particular machine that I have that belonged to Telarc has been retrofitted with a later version of the DAC card, which uses a different integrated DAC circuit. I don't know its manufacturer model number. The DACs are clocked along with the output of the data transmitter card with the 50 kilohertz sampling rate that's derived from the 2 megahertz crystal oscillator. So that's one of the earlier cards. The DAC audio outputs are followed by low-pass filters and buffer amplifiers. The output is transformless balanced on the rear panel of the electronics unit. So in the AES presentation, I had the master tape from this 1812 recording. I had gotten it from its resting place at Iron Mountain. And we actually played it back over these gigantic PMC loudspeakers, and it was quite a thrill. I'd like to just tell you just a tiny bit about this recording, even though we can't play this back in this session. Um, the recording was of Tchaikovsky's 1812 Overture. It was recorded by Telarc founder and chief engineer Jack Renner and produced by Telarc co-founder Bob Woods. The recording was made during the fall of 1978 and released in the fall of 1979. It consists of 3 separate stereo recordings that were mixed using special custom mixing software on the Soundstream DEC PDP-11 computer in Salt Lake City. The orchestra was recorded using Jack's typical setup of 3 Schoeps Omni microphones. I believe he used MK2s at the Music Hall in Cincinnati, Ohio. It was edited into a complete orchestral track before the other elements were added. The carillon that's featured towards the end was recorded shortly after the orchestral session in Marymount, Ohio, where there's a large outdoor carillon, and they set up the machine and recorded the carillon parts there. The cannons were recorded at Baldwin Wallace College near Cleveland, Ohio. And there's a funny story. I've heard the original source canon recording, and of course, you know, they had no idea what they were getting into when they set up to record these canon shots. So they just like guessed, you know, where to put the microphones and you know what the record level should be. And when they first blew off the first canon charge on the tape, it's hilarious because all you hear is this little tiny click, and then it goes to dead silence because it bottomed out the B&K Omni microphones they were using, and it took them a fair amount of time to recover. So then they had to experiment with miking further away and using also smaller powder charges in the cannons in order to get a reasonable cannon sound, but without damaging the equipment. The initial cannon shot also, they used a 5-pound powder charge, and it broke out some windows in the Baldwin Wallace English Department building, which they had to repair. So that's the end of my presentation. Let me bail out of this.
That's really awesome about the Canon charges and the microphones. Were they close miking the Canons then?
Well, I don't know what the actual distance was.
But it was too close.
But whatever it was, yeah.
The first setup was way too close.
That's very similar to what Mercury had.
Yeah.
But yeah. Everyone underestimates what a Canon does to a microphone.
I don't know why you would. I mean, that's silly.
I did a similar thing with Canon. It was actually sort of like they use in fireworks, you know, the sort of mortar shell things. And they were behind the stage that I was doing live sound for, and bang, 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 off went the cannons. Complete silence except for all the amplifiers resetting and clicking back on it. For a bit, for however long it took them to restart again after the cannons went off.
Well, I have a question.
Yeah.
With going back to the tape machine, with the azimuth adjustment, is it possible is there enough leeway in the azimuth to get a full 180 degrees out of azimuth so the pulse would line up, but it would be the next pulse?
You know, I don't know the answer to that.
Apparently not, because at least not the way you align it, because you succeeded.
Yeah, I'm really not sure how to answer that.
I know from my experience with similar gear, you showed that waveform, which was sort of a sinusoidal signal, and how you get back to TTL logic is to boost the gain on that and then clip it so that
I wondered if that was the the solution, or if they did some kind of like half wave rectifier. So it's basically they just force it into clipping.
The clipping essentially would do that, essentially running the signal between a pair of bias diodes that had a 5-volt difference from zero to 5 volts, and that's TTL. So
thank you for explaining that to me. I've wondered about that for a long time.
Or a threshold detector, which just flips the voltage from 0 to 1 at a certain threshold as the sine wave goes up and down.
Okay.
Well, that's the same idea. So,
Luke, do you have that video available to play now?
Yep. Just give me a second.
So let me just explain what this is real quick. This is not the 1812. There are a number of recordings that that Telarc made on the Soundstream that were never subsequently released on either CD or on SACD. They were only issued on the original LP phonograph record versions back in the early days of the company. And there's been some interest with Concord's deep catalog label called Craft Recordings in re-releasing these LPs as they were done in their original release, and also with the original artwork. And so I've had to retrieve some of these recordings because they didn't exist any place other than still on the Soundstream tapes. And this video that we're going to see is I had to retrieve a recording of Hindemith's Symphonic Metamorphosis on themes of Weber. And so that's what this playback is. It's not the complete work, it's just the beginning, but you can see in the video what the transport looks like when it's operating, and you can also in the background see the oscilloscope and see what those waveforms look like when it's in action.
Okay, I'm going to give it a go here. I would say everybody should mute unless there's a problem, and then speak up. But here, we'll give it a shot. All right.
That was great. Thank you so much for playing that.
Hopefully it looked all right.
It looked great.
Yeah,
Yeah,
it looked
really
great.
good.
It sounded good here as well.
So, Paul, are you doing direct digital transfers, or are you going out to analog? And
for this one, I had to do analog using the original DACs, and then fed those analog into a merging A to D converter. And the reason I had to do that is there's something went wrong with the there's a pair of custom cards that Francisco Rodriguez, who used to be a staff engineer at RCA, who had a lot of knowledge about the Soundstream, that he built for Telarc back in the late 1990s. And something went wrong with one of those cards, and I couldn't get any data output. So I had to resort to putting the D to A converters back in and just doing an analog transfer rather than a data transfer. That's a problem that I'm going to have to address. There's also a problem. There are more tapes that need to be retrieved, and unfortunately, the Soundstream machine has stopped working right now. I think that the bipolar 15-volt supply has died because the logic functions and the transport control all work normally, but none of the audio cards are working, which would indicate the bipolar 15 supply may have crapped out. And so as soon as COVID is over and I can, without a lot of risk, either get this thing to a qualified electronics person in Nashville or get somebody into the studio to repair it, it's kind of sitting. And at the same time, I'll get those cards looked at as well to see if we can figure out what's going wrong with that.
is Frankie still around?
You know, I don't know. I've lost contact with him, and the telephone number that I have for him, he was in Pittsburgh, it doesn't work anymore. So I don't know what's become of him. I haven't heard from him in years.
The question I had is on the top of the transport on either side, there are some controls that one looks like a series of analog tape speeds, so like 7.5, 15, 30.
Right.
And there's a speed, like another switch next to that. Can you explain those a bit?
Yeah, that transport was designed and built by Honeywell for a number of different functions, and so it had multiple speeds. In its data recorder setup, it would only run at the highest tape speed, and then they also made an iteration of that machine that had analog record heads, and it ran at a very low speed and was a multi-channel audio logging recorder. So they just had the single transport for all those different versions of the machine. On the Soundstream version, those speed controls are no longer active because the speed of the capstan servo is all controlled by the electronics.
And Paul, you have to bake those tapes, right?
Yeah, that variety of Ampex data tape does suffer from sticky shed, and so it does have to be baked before you can play them. Once they're baked, they actually run very clean with very little shed.
I had a question about the speeds. Didn't you say early on that it went at either 30 or 35 IPS?
Right, and that was controlled by a toggle switch on the one of the servo cards in the electronics, not by the speed switch on the transport.
Okay, and that doesn't seem like much of a difference in speed. What was the purpose, or what was the result of each speed?
The original machine ran at 35, and they discovered that they could slow the tape speed down slightly and get a longer record time on the tape, and that 30 IPS would still make it capable to record 50 kilohertz 16-bit.
Okay.
And that's another thing about working with these old Telarc tapes is, unfortunately, nobody bothered to note on the boxes which speed they were recorded at.
Oh, no.
And so there's very little documentation on the tapes, and so there's a certain amount of trial and error anytime you thread one of them up to figure out what's going on. And I've always been very careful then about marking a lot of details on the boxes.
Does it not work?
I wonder if there's further documentation on those tapes at the Tom Stockham Library with all of his papers.
Gosh, I have no idea. That's a very good question.
There may be catalogs and so on in the library, but you'd have to go dig,
Right.
Did I hear this correctly? You were dubbing from analog domain into merging A to D converters. Was that to direct stream digital or just a high sample rate?
Just a high sample rate PCM, because there'd be no advantage to recording the 50 kilohertz PCM into DSD. There's no increase in fidelity of what you started with. So I just always record when I have had to do analog transfers like that. I've just used 96K because that's capable of getting everything that's on the audio bandpass of the tape.
You had mentioned something about there being essentially a delay for vinyl cutting for the essentially a preview head. How did that fit into the 2 versus 4 tracks? I didn't quite.
Okay, when the session recordings were just done direct to stereo, so they used 2 channels. The editing was all done at the facility in Salt Lake City using that DEC mini computer. And then laid back to a new reel of tape, not going through A to D and D to A conversion again, but the actual data stream. And then they had a digital delay device where they could at the same time record the same program onto the 4 tracks, 2 of the tracks being delayed, and so the delayed tracks became the program audio, and the non-delayed tracks fed the variable pitch depth computer on the cutting lathe, and the amount of delay was whatever that exact time difference is, 1 revolution of a 33 1/3 RPM record.
Okay, so it wasn't really as if the machine had an inherent kind of delay capability. They just kind of kludged it together using those additional.
Right, they just kludged it together, exactly. One of the things that became very beneficial when I was doing the remasters for SACD release was that oftentimes there would be dropouts in one of the other sets of program, either the program or the preview. And so I would transfer each reel 2 times, one time transferring the program audio into the Sonoma system, and the second time on a different set of DAW tracks, the preview audio into the Sonoma, then manually line them up, and then you could go through and edit back and forth between program and preview to eliminate any dropouts.
Sounds like a pain in the ass.
Well, I mean, it's audio production is a pain in the ass, but it has its rewards. The largest project that I did, which took a considerable amount of time, was Telarc had made a very well regarded recording of Mahler's Second Symphony with St. Louis and Slatkin and an array of stars in the solo vocal parts, and Telarc very successful when it was originally released, and Telarc wanted to re-release it on SACD, but they didn't want to go back to the edit masters because that's one of the recordings that was downsampled to 44.1 and then edited on a JVC U-matic based audio editor. So I went back to all the original session tapes with all of the original log sheets and transferred all of it into the Sonoma DSD workstation, cataloging the take numbers in track markers as I went along, and then using the original music scores that had been used when they did the JVC edit. I completely re-edited the entire work. And in the process also was able to fix a number of musical problems that they were not able to edit using the JVC system because it wasn't as flexible as the kind of editing that you could do on the Sonoma DAW. And that was re-released on an SACD that's unfortunately out of print.
Hey, Paul.
Yeah.
I'll do a little show and tell for everybody.
Oh, do you have one?
Yeah, this is Paul's SACD. Can people see this of the Fred Fennell? And so this is the SACD of the original Holst Fennell, and then this was the original LP right there. And hopefully it's not backwards like it is on my screen.
Nope, it's the right way.
But you know,
you don't have that Mahler 2, do you?
No, I don't, unfortunately.
Yeah. I don't have a copy of it either, and I found copies of it on eBay, and they cost a fortune.
I think I may have the CD of it still.
The SACD?
No, this regular CD.
Ah, the regular CD
probably not useful for you.
Yeah, was edited on the JVC system, all at 44.1. The SACD release was completely re-edited from the 50 kilohertz PCM upsample to DSD.
And Paul, you don't have your master files?
Unfortunately, I do not have that title because that was done in 2001 or 2002, before Telarc was a part of Concord, and Telarc had a very arcane way of doing data backups that used a lot of AIT tapes, many of which are, I don't even know where they are. And I don't know if you guys have had any experiences with trying to restore data from AIT tapes, but they're a train wreck.
It's interesting that one of the very first digital recordings I ever did with the BBC was actually a Holst. It was Holst of Planets.
Yeah.
In Glasgow.
Yeah.
They actually built a hall. Well, they finished converting an old church into a recording studio for the Scottish Orchestra, Scottish National Orchestra, and the BBC kind of put extra money in it to get it finished in time for the schedule for the radio program and whatever. I remember the bit of a panic with that, but that was recorded straight to a U-matic. I think it was a 1610, Sony 1610 on the inlet end, and a couple of Panasonic DAT tapes as safeties. I remember that. It was a good laugh.
Paul, I had a question about the scored capstans.
Yeah.
Didn't those eat away at the tapes? Reduce?
No, because they only made contact with the back coating.
Okay.
Remember, because of that screwy threading pattern,
Yes.
the back coating actually is the only thing in contact with the capstans, because the oxide is reversed.
Yes.
As you wind around all those different idlers and guides.
Yeah, I followed that, but doesn't it eat away at the back coating?
No, they're not that abrasive.
Okay, cool. And you showed a picture of it in use, I think, with the top cover off. Was that the standard operating condition, so you could see those LED lights that would light up if there was issues?
No, I've just always used it with the top cover off, so I could look at things like that. Also, if you used it with the digital output cards that Francisco built, those would actually slide into the same card slots as the DACs, and their output was SDIF2. And so there were BNC connectors on top, and so you couldn't put the lid back on because you had to have BNC cables hanging out of the top.
Yeah.
But when those machines were used in session and also for any other application back in the day, they were all buttoned up.
Okay.
Say it sure was disconcerting seeing the reels going the quote wrong direction.
I know it's really, it does a number on your head when you've been used to seeing tape recorders your whole life, because everything is going the wrong way.
But they're both going the same way. That was
yeah,
the thing
yeah.
To me,
I have no idea why Honeywell would design a transport to operate that way. It seems like an unnecessary complication, but I'm sure they had their reasons.
It was sure a lot of twists and turns in the feed for that, because it was that way.
Yeah, and threading them, is kind of a pain, because the spaces between the guides are actually quite small, and so in order to thread one, you have to reel off several feet of tape and then gingerly wrap it around all those different guides.
Mm-hmm. And you said that the frequency response of it was 400 hertz to 500 kilohertz. Is that typical for this kind, for digital? Is that the kind of frequency response you need to handle a digital signal?
That I don't know. I mean, I know the reason that Sony used video recorders for their recording systems is because the bandwidth of black and white television was roughly what was needed to be able to store 44.1 16-bit data.
And that was the spinning head idea too.
Yeah, those were all helical scan.
Yeah. Huh. Okay.
Paul, you have 4 tracks going at a time for each audio channel, correct?
I'm sorry, say again?
4 data tracks per audio channel?
No, two data tracks per audio channel. So, for example, if you were recording...
I don't mean the main track and its redundant pair, but I mean for each... There were 16 total tracks on the tape, correct?
Right.
And you could record 4 independent program channels.
Right, and that would only require then 8 data tracks, because each audio channel requires 2 data tracks.
Got it. Thank you.
Okay.
That cuts the bandwidth requirement in half.
Paul,
well, what it does is it allows you to use the tape for 2 passes.
Paul?
Yes.
John Vanderkoy has a non-working unit.
Yes, I spoke with him about that at the AES in 2017.
Well, the important thing is he has boxes of tapes. And so I hope he gets in contact with you to discuss all of these tapes he's got.
I wonder what those are.
Well, he does too.
Hello, Paul.
Yes, hello?
Hello, Paul. It's John here.
Oh, hi, John.
Yes, I do. We do have. Hello, Paul. We do
Hi.
have boxes of tapes, about 19 boxes. They each contain about 6 tapes. Many of them are demo and test tapes, and I don't really know what the others are. I guess what I would like to find out from somebody, if there's a listing on any of Tom's stuff, whether he talks about what's on the tapes or whether there's a log of that anywhere.
Bill was also asking about that, whether or not there might be something in the in his archives in Salt Lake City, and that I don't know.
Yeah. Okay.
Hey, Paul, if you get this machine ship shape again, would you think it's important then to just do all the Telarc tapes you have? And maybe get with John, and because like you may have the last soldier standing here.
Yeah, I know. what my intention is, if we can get it running again, is to transfer all the stuff that was not already transferred to DSD.
Right.
There's already a substantial amount of titles that were transferred to DSD. There were a whole series of Telarc SACDs that were Soundstream re-releases.
But you don't have the master files for those.
No, those are no doubt backed up on AIT tapes somewhere in Iron Mountain. Now, the one fortunate thing is that another gentleman who was on the staff at Telarc, who is still with Concord, has the complete library of all the Telarc CDs and SACDs on physical discs.
Oh.
And Gus Skinnis at Super Audio Center in Denver has a way to retrieve the DSD data as a DFF file directly from a physical, optical SACD. And so there have been a number of occasions where they've wanted to repurpose and re-release things that were released on SACD. And what we do is we send the SACDs to Gus and get him to rip the DSD audio, and I have a whole catalog of those on my server.
So if you have the right player, you can do it yourself.
Right. The reason we have never reinvested, those players are extremely expensive. Ed Meitner at EMM Labs in Canada used to make an SACD player that had SDIF2 data outputs, and you could record in real time directly from an SACD into a comparably equipped DAW like Sonoma. He stopped supporting those machines. The one that Telarc had died. And so now, as far as I know, Gus is the guy, and for what Gus charges, it's much more from a commercial standpoint to our benefit just to always to go back to Gus to get this done rather than invest the substantial amount of money that it would take to buy one.
Unfortunately, I think they're all no longer made, but I know I've got an Oppo 103, just a consumer Blu-ray player, and somebody's written some software that just connects to that over Ethernet, and then you just get an ISO image of the SACD from there, and then you can extract to a DSF or whatever you want from there.
Wow, I'd love to know about that because I have a couple of Oppo players.
Well, a month or two ago, I kind of just discovered this, and I started ripping them myself, and I actually mentioned possibly doing a presentation, so maybe we'll have to do that sometime soon.
That would be great.
I have an Oppo player too, so if you get anything posted on our list so we all know about it.
Yeah, unfortunately, it's not. It's only specific models. I know it's the 103 and maybe the 105. I'd have to look, but it's something specific to a particular chip inside.
What do you have to? Do you have to upgrade the firmware or something to install this software?
No, the only thing you have to do is you download. I don't remember the details offhand, but it's a piece of software. You put it on a thumb drive. You put the thumb drive in the front of the Oppo, turn it on, put an SACD in, and then you use some software in your computer to say, "Oh, connect to the IP address of the Oppo," and it just essentially just downloads an ISO to your computer.
Interesting.
And let me point out, which I forgot to mention earlier, that for the new people here, we have a mailing list going on, that there's discussion during the week between these meetings. And if you want to be added to that mailing list, email list, send me an email and I will add you to it. I will not add you to it unless you do that. But there's a lot of great discussion. Luke talked through that Oppo hack a month ago or so, and many other great discussions too. So send me an email. Okay, back to the discussion. Thank you.
So I have a question actually for Yukio. Are there any working Denon machines left in Japan?
You're still muted.
You're still muted, Yukio.
Sorry, I have muted. Yes, the machine of the third generation, 4 channel, oh no, 8 channels, 16-bit. This machine DN034R is still working, still in operation, and the Denon is still re-releasing the older catalogs using this machine. Even the very first recording made in 1972, this machine can play back.
Really?
Yes.
Does it need a different video transport?
Well, we are still keeping the original video recorder.
Oh, so all of the tapes use the same video transport?
Yes, the machines are still carefully maintained by one expert from that time, my colleague from that time.
Unbelievable. That's neat.
Yeah, therefore, our digital recording archive of tens of thousands tapes can be played back still today.
Bravo.
I just put some very high-level stuff regarding SACD ripping in the chat, just kind of details about the chip and some of the players and things. So I know there's another way to do it with early versions of the Sony PS3, but I'm not familiar with that. But I've done this method and it works. So
can I ask a question? Can I ask a question of Paul Blakemore, please?
Go ahead.
Are you still there, Paul?
Yep, he's.
Paul, you said that tapes needed to be baked. How important is that, and what do you do? How do you do that?
The tapes are unplayable without baking.
Stan and I did a lot of work on dither, and we wanted to find other people that had done work on dither. We found out that a number of people in the MIT labs that had been there knew things about it. One of them was a guy called Nelson Wright, and we found out that Tom Stockham also knew these things. And so we actually asked Tom, whether he could show us his notes and so on, because we wanted to be sure that the dither was the same. And he did. He showed us his notes, and would you believe it? It's just like the theory we had. I mean, it's just amazing how he had. Anyway, so we made him a co-author on the paper, and you'll know that from the history of those things. It's really interesting. Tom never told anyone because the KG guy didn't want people to know why his recorders sounded so damn good, right?
It's a good story.
I remember that there were adjustments on the A to D board which would allow you to set on the DAC and on the ADC board in such a way that that any non-monotonicity exactly near audio 0 was canceled, was gone. And so his 16-bit recordings were the first recordings that really made 16 bits. And I think we all know that if a 16-bit recording is properly made, it's pretty good. And
not bad.
So, yeah.
Huh.
That's great. Thanks for telling us that one.